Engine y más. Vamos a empezar con la presentación de Chris Schalk, utilizando las funciones más recientes de App Engine. Chris es Developer Advocate de Google y trabaja incorporando comunidades de desarrolladores a la nube, utilizando Google App Engine y otras tecnologías de Google. Y bueno, antes de unirse a Google, Chris era gerente principal de producto en Oracle y trabajaba en el grupo de desarrollo de herramientas y es coautor de Java Server Faces de Complete Reference. Entonces vamos a darle la bienvenida y bienvenidos.
Gracias. ¿Me escuchas? Hola, hola. ¿Puedes oír? Testing, 1, 2, 3. Can you hear me okay? It's okay? Or no? No, it's not okay. It's not okay. Can you let you check it? Okay, testing 1, 2, 3. Hola, yo soy Chris Schalk. Estoy aquí en México. Ah, tal vez es mejor. Muy bien. Bueno, voy a sacar una foto. ¿Está bien? Ok, este lado aquí y este. No, broma. There we go. Voy a poner en Google Plus. Bueno. Mi nombre es Chris, o otra vez. There we go. Ok, ¿listo? Estoy presentando. Ok. Bueno, mi nombre es Chris Schalk, yo soy un Developer Advocate y estoy pensando tal vez voy a hablar en inglés, ¿está bien? Para hablar sobre cosas tecnología y si después, si necesitan hablar o preguntar en español, está bien, yo puedo contestar en español, creo. Bueno, vamos a ver. Pero esta presentación es sobre App Engine y las cosas más nuevas y voy a hablar mucho de muchas cosas. Tengo que, bueno, voy a cambiar a inglés a este momento. Ok, everyone ready? Here we go. There we go. So here is my agenda. First of all, how many people have never worked with App Engine, have never used App Engine? Ah, okay, good. So I did put some content here for you. For the people who are not familiar with App Engine, I do have some introductory content to explain what App Engine is. And then for the rest of you experts out there, I will be talking about the new stuff and explaining from a historical context where App Engine has come, what are the features that we have today, and a little bit of what's coming up very soon, a very important feature that we expect to. So I'll be touching on the various features that you may have heard about, such as the Go runtime, backends, channel API, and so forth. Okay? So first of all, what is App Engine? App Engine is essentially a set of APIs that allow any developer to make use of Google's infrastructure. So for example, and it's also one of the most important points is that it's targeted to be easy. So it's easy for external developers to take advantage of Google's storage technology, so Bigtable. It's easy for developers to build applications that use, any number of internal infrastructure technologies that Google has, except for now, external developers can take advantage of it and be quite productive. So it's also one of the nice things about Google App Engine is that since it's using the overall Google infrastructure, it can scale. It can go up to very large numbers. So if you have an idea for building an application, you don't have to worry if you have lots of traffic. App Engine that's one of the main strengths of App Engine, that it can scale up to very, very large capacities without you even having to do anything. Okay, so how does App Engine fit in the overall landscape of cloud technologies? So this is kind of like, so if you follow cloud technologies, it's typically divided in 3 areas. So for example, this is a Gartner classified different cloud technologies. Obviously there's the software as a service, the SaaS, where you have simple applications where you just use the software. You don't actually build anything. It's just using Google Docs or Google Apps. And then if you drop down, you're actually using a platform as a service. So these are actually development platforms as a service. And Gartner has identified App Engine correctly that it is a application development platform that you can build, for applications in the cloud. I would say the middle area is the most diverse. So the App Engine is, although at a high level, is kind of similar to some of the other cloud technologies such as Windows Azure, Force.com, in the sense that you use those technologies to build an application that you deploy to the cloud. But I would say App Engine is also very different, as all of these technologies are quite different from each other because each has their own specific technologies that they use, which are not necessarily the same. And then finally, the infrastructure as a service is the more traditional cloud technologies where Amazon and VMware and Rackspace, they are providing low-level infrastructure. So instead of you having to purchase your own machines and put them in a center and keep the cooling fans on them, they take over that process. So anyway, let's go ahead and focus in on App Engine more specifically. What is it? So I mentioned it at a high level. It's a very simple set of APIs that allow you to build your applications. If you drill down a little bit more, it's actually an entire application development toolkit in a box. So this comes with a downloadable SDK, so a software development kit that you can download from the website that we have, and then you can start beginning to build your applications. You can test them locally, and then when you are comfortable with the application, you can then deploy it to the cloud. And then from that point on, you can continue to maintain it, and you can deploy new versions of it so far, and then you become operational. So that's more or less how App Engine works. It's actually fairly straightforward. Now the runtimes provided, Python was the first App Engine language that you could use, and then later on Java became another additional language that was supported. We now have a third language, Go, and it's experimental. So it's essentially just trying it out. There are people at Google that are using Go, and they thought it seemed reasonable to try it out on App Engine as well. Okay. So as I mentioned before, App Engine is a series of services. This is just a sample of some of the services. It's not all of them because obviously we have a whole large number of services. But basically, as I mentioned before, like the data store is basically allows you to use the same storage technology that the Google search engine uses, high-speed memory caching, Memcache. So it's essentially using the same high-speed memory caching that the entire Google infrastructure uses. There's other email support, XMPP for chat, task queues, which we'll be talking about in more detail later, for doing offline processing, and so forth. Other easy to use, straightforward services. And the goal of these services is to make these complex internal infrastructure services from Google very easy to use to an external developer. Okay. Oops, there we go. So let's talk a little bit about some of the production updates that have come about with App Engine. And by doing that, I want to explain a little bit of the history of where App Engine has come along. So back in 2008, App Engine was a very simple technology. The numbers were, well, they were thousands, but as you can see, the growth of App Engine has been significant. Every year it continues to more than double itself. So it's definitely not linear. And as you can see, the various features have been added along the way. So as you can see, Java was introduced in 2009. We have a whole host of new features that got introduced between 2010 and 2011. And of course, today I'll be talking a little bit more about the latest features that we're focusing on today. So how many people are actually using App Engine? This is a very modest number, 100,000 active developers. The actual numbers are a bit higher, but these are people that are not just using it once and then leaving it. These are people that are actively engaging with the product and consistently updating their applications and essentially becoming successful. And then we have over 200,000 active applications that are registering traffic on a weekly basis. And then the actual usage is quite large. And this number is a bit dated. This was the number we communicated back in May of, at Google I/O. It's actually closer to 2 billion page views per day. So all in all, as you can see, the App Engine infrastructure is built to scale, and it's continuing to grow on a very aggressive pace. So just some background information. These are some of the notable App Engine customers. They've been successful in a number of ways. Some of them you may recognize, some of them you may not. So it's App Engine has a broad range of customers. Some of them are startups, some of them are more traditional enterprise. Okay, whoops, here we go. You may have noticed the royal wedding had an official blog, and if you followed the blog, it would give you the links to go and to watch the overall proceedings of the royal wedding. App Engine actually was fortunate enough to serve as the official blog, and one of the things that we feel very proud is that it actually was able to handle staggering high numbers of traffic, up to 32,000 requests per second. And in that one period, you know, right during they got married and there was the kiss, there was over 37 million page views and 13.7 million visitors. So anyway, just some background information about App Engine. Here's some other companies that have had success, like Best Buy. Best Buy has built various applications, gift tag or 12th Force, and so. And actually, is Best Buy here in Mexico? I'm not sure. It is, okay, good. I figured it might be, sorry. And then this company over here is Web Filings. And the company itself is small, but I already talked about that. But the company itself is small, but it has a number of very important customers. They provide a financial reporting service. And so these are the customers that they have on their website. Because I talk to them regularly, they even have more. They're actually over 500 customers, and a lot of them are very well-known customers from Fortune 500 and even Fortune 100 companies. So essentially, these large companies are relying on App Engine technology to handle all of their financial reporting. Okay? And then another very important point, especially in the enterprise world, is App Engine, and this is an update just as of like a few weeks ago. It has completed its certification of the various security standards. So SAS 70, or it's formerly known as SAS 70, but it's now referred to SSAE 16. But basically, if you are following enterprise security, these are pretty typical standards that you're looking for cloud or web technology providers to be able to adhere to. So it does say that, you know, essentially App Engine is a very secure technology. Okay, and then of course this other important production update is that App Engine is coming out of preview. So App Engine has been a beta product since 2008, and even though the growth has been very significant, it's still been a beta technology. But as we continue on this year, the App Engine technology is then going to be coming out of preview, and that actually means some very nice things in that, well, let me jump ahead. I have one slide here. What does it mean to leave preview? Well, in short, it means that it's a long-term commitment by Google to App Engine, meaning that App Engine wouldn't just disappear. It's here for the long haul. Like for example, there's various Google technologies that sometimes they don't stick around. I don't know if you remember one, like last year. Yeah, so. But the nice thing about App Engine is that it's becoming a production technology. And that means it won't disappear. It'll be here for the long term. And so that's a commitment by Google directly to App Engine, and of course, a long-term commitment to App Engine and its users. And so speaking of commitment, the nice thing about App Engine, the production version of it, which is, you know, coming up later this year, is that it will have at least a 3-year deprecation support. And it will have, most importantly, an SLA. And an SLA is very important for our enterprise customers in the sense that they need to have like a certain level of service that they can count on. Before that, we did not have an SLA, but now that we have a new support channel that we're putting together that will allow us to essentially maintain all of our technology up and running. And so yeah, the App Engine technology is maturing, definitely. Okay, I'll just jump ahead here. So what does the production App Engine offer? Well, the pricing is a little bit different. There still is a free usage model where anyone can start and work with App Engine without having to pay anything. So this is good for prototyping, good for startups who just want to get familiar with the technology, or even students if they want to try it out. But what we are offering is two paid models that, for example, one is not very expensive. This does provide an SLA, but it does not have support. And then, of course, this one here, the Premier, which is what we expect our enterprise customers to have, is essentially $500 per account per month, plus the usage, which I'll explain. And then, you know, the most important thing for them is the operational support. So that way they can call or log a ticket and then have anything addressed. Okay, and then there's of course additional add-on fees for special services. SSL for custom domains, that's in progress. It's going to be coming out as well. I can't give you the exact timeline, but essentially it's part of one of the features that we will be offering with our App Engine for production. Okay, a few different small changes with regards to pricing. It's based on instances, which is a slight departure. So CPU hours are now being replaced by instance hours. And so if you're familiar with how instances work in the admin console today, that's more or less, you can pretty much understand. So the idea there is just, if you want to kind of conserve your budget, I guess, you can kind of work your application to make sure it's not using too many instances. Okay. So yeah, and there's definitely some FAQs available that you can look at. And one thing I should say is I have a lot of links in the presentation, and so, you know, of course you'll be able to get this presentation on your own, and you can click on the links just so you can see exactly what I'm referring to. Okay. So let's talk about the a little bit more of the technical updates. So App Engine 1.5 was released in May of 2011, and it was a fairly significant release. We introduced it at Google I/O back in May. And as I mentioned before, Go was actually one of the features that we introduced back in May in 1.5.0, and then now it's essentially, as of 1.5.2, it's kind of launched for production. So it's essentially a little bit more mature now. So you can become a little bit, you can do a lot more now with the Go implementation than you could before. Now this is a very important point, the high replication data store. So how many people here understand what the high replication data store is? It's okay. So I can give you a bit of a background. So when App Engine first launched, it had this architecture known as master-slave. And the positive aspects of this architecture was that you could have very low latency, and your application, you know, would perform quite well for the most part, except for when there could be some contention with other resources that were also using the same shared infrastructure. So what happened was occasionally you would get latency spikes. So sometimes just the amount of time it took to talk to the data store to retrieve data could sometimes go up higher than you would expect. And especially if there's enterprise customers or large companies that, you know, absolutely need low latency, this was not quite working out so well. So in the last 2 years, we have a new data store architecture, which is now referred to as the high replication data store. And if you're familiar with this particular computer science term, the Paxos algorithm, basically it's a way that ensures consistency across multiple entities eventually. So it's not extremely fast. It's not as fast as master-slave, but it's more consistent. And you have a predictable manner by which you expect for the performance. So the performance is predictable. It's a little bit slower, so you have to factor that into your application. But as you continue to work with it, you'll notice that it's very solid and it will perform as expected. And it's also had extremely high uptime. It's 99.99% uptime since we launched it. We've been having lots of positive reviews on it. And I should also say the HRD data store is now the default data store technology. And if you also want to use once the production version of App Engine comes out, if you want to take advantage of the SLA does require the high replication data store, because there we can guarantee like a certain level of service. Oh, the other very important point about the master-slave or the high replication data store is that originally the master-slave technology would have to schedule some downtime. Periodically, you would have to schedule what we would refer to as failover, where we essentially take the data and go to another data center. This is not the case with high replication data store. It's always on. You do not have to take your web applications down at all. So that's obviously a great feature for a lot of our customers who absolutely have to have their applications running constantly. Okay. I think I touched on most of these points. The price is, originally we were thinking it was going to be higher, but we were able to bring it down. And the master-slave price is actually coming up a little bit. So essentially the incentive is to use high replication data store. Okay. Now there are some better tools that we're also in progress of working on. Because right now, when you want to migrate from the old data store to the new data store, it can be a little challenging, I guess, a little bit. For example, if you have hard-coded entity or keys, and you put them into a publicly facing URL, then you could have the possibility that you need to make your code still behave the same manner that you had before, because the key values themselves actually change when you switch to the new high replication data store. But we are working on tools that take care of, here we go. That's funny. Oh, well, no worries. We are working on tools that will take care of that, so you can do the migration much easier. But originally, it took some work, and we had to actually launch our own MapReduce jobs to copy the data and then apply some aliases. Okay, but we're getting there. So let's talk about some of the new features. Backends. Backends is, how many people have heard of backends? So backends is a technology. It was introduced also at Google I/O. The idea there is that it's meant for just long-running processes that may never even quit. They could just keep running, and you can define exactly what your instance that you want it to be. So it's a different thinking of your, like traditionally App Engine, you would go with short requests. They would have to finish fairly quickly. You did have the capacity to use task queues or cron or things that could do offline processing, but they also had limited lifespans. This is different. This is actually, you can configure your own back-end server and let it run. So it's literally like you had your own computer, plugged it in, turned it on, and that's your back-end server. And you can configure it to work in tandem with your front-end instances, which may be handling requests, or also working with task queues and cron jobs to relay jobs to send off to the long-running server processes, which are the backends. I think some of the examples of backends could include like web crawling, so just going out and doing lots of data processing on a continuous basis. That's probably the most obvious example that I can come up with. There are some differences or some key distinctions in the sense that, there we go. You can make them resident or dynamic. Resident merely means that a backend can run just constantly, and then regardless of whether anyone's doing anything with it. So the other option that you get is, there we go, is dynamic. So this is a setting on the backends where you can just have it start up based on any kind of requests that are coming in. And of course, some other features, you can make them public or private. public merely means that you can have a URL or publicly accessible URLs and stuff, or ways to interact with your backend. Okay. If I have some time, I'll go ahead and show how to configure them and run them. How are we doing on time? 11:18? Yeah. Okay. I'll probably come back to that. So another technology just to talk about. This was also introduced at Google I/O in May. This is known as a pool queue. Now, pool queue is very similar, well, it's sort of similar to original task queues, but there's a few small distinctions. And it provides, I would say, a little bit more flexibility to what we originally had with task queues. I think my battery's starting to run down. Yeah. Oh, well, I won't use this too much. So it provides a slightly different usage model for offline processing. I think the next slide probably sums it up best, in the sense that in traditional sense, task queues is based off of this main task queue service, and your application essentially is handed down each tasks. So, like, first of all, you would queue up your tasks into like a whole line of tasks, and then when the task queue service itself has essentially defined when your application should run those, it will then take the task off of the queue and hand it to your application and so forth and do that and let it run. So the difference with the pool queue is that the pool queue is a little bit, it's like instead of the task queue service pushing out tasks to individual applications, it's more like you can create your own code or worker code that will pull individual tasks on their own, and you can do this at whatever time you like to. So it's more or less like you can line them up, your tasks, and you can enqueue them, you can define them as a pull type of a task, and then you can have any bit of your server code go ahead and pull it when it deems that it's necessary. So it just provides a little bit more flexibility on the different types of tasks that you can do. Okay. And I should say, we refer to pull or lease. You can lease these tasks, and that's essentially how you do it. Also, very importantly, the tasks are addressable via a RESTful API. So in this sense, you could actually refer to an individual task via, a URL which specifies that it's a task queue, and it's, you give the application ID and then the actual name of the queue. And so in this sense, the tasks themselves are not purely bound within an application, but can be shared in multiple ways with different applications. And then you can also define the ACLs, or essentially the access control lists of how the other people can access, or other entities can access your task queues. So anyway, there's definitely a nice session that I recommend if you're very interested in that. This will go into a lot more detail in explaining how the pull queue technology works. Okay. I think I covered most of it. Tasks are pushed. You can execute at a given rate, just more flexibility. And then workers. Workers are essentially your server-side code that you decide that can, go ahead and lease or pull a task when it deems that it's necessary. Okay. So let's talk about some of the other updates as of App Engine 1.5 or 1.50. And these have all been posted on our blogs as well, so you can read up a little bit more detail on them. But the email API has been updated a little bit. Mainly, the idea here was that to just make sure that it was fully available. And so it actually did decrease a little bit from like the large free number of emails that you could get to a little bit smaller. And this is for the free. You can always pay for more, but from the free quota, it did come down a little bit. A small update with regards to source code downloading. So if you want to download the source code before it was just limited to like the owner, but now you can do both the owner or uploader of the actual source code. Okay. In version 1.5.1, there's a nice new feature that now we're providing that allows web developers to take advantage of the location. And so essentially you get access to the header called X App Engine Country, where then once you parse that yourself, you can define how to create the content. So that way, if you can actually guess what country they're coming from, and then that could allow you to auto-populate a particular web UI so the user doesn't have to pick their own country. So that's a nice little, small little feature that you can take advantage of to make your web applications better. The channel API. The channel API, how many people are familiar with the channel API? So the idea with the channel API is server-side push, so commit. So essentially, you have server changes and you want to push out those updates to your web front end. So it's a very fun technology. If I have time, I can show you a demo of how that works. But basically, the channel API was quite a popular feature when we announced it, and then all we're doing with this particular release is adding a little bit more functionality where you can detect when a user connects to your channel, essentially, or disconnects. So that makes it a little bit easier to do some house cleaning and so forth. WebP support. So if you ever heard of WebP, it's actually a new open source standard for images that are almost as good as JPEGs, but 39% smaller. So this is now also available in the Google App Engine Images API. And of course, RPC services, so Proto-RPC is essentially building, again, off of internal Google technology, protobuf and essentially RPC calls where you can essentially build up your own sets of services, web services, so forth. So high-speed web services you can build using this technology. So anyway, there's definitely more content there on that particular blog post that you can read up on these updates for 1.5.1. And then 1.5.2, which is actually what we have today, is there's a few interesting things that came out. There are now adjustable sliders. So in the admin console, you can actually define either the minimum pending latency or the maximum number of idle instances. So this is good for people who want to kind of manage their instances and make sure they're not using too many and so forth. So it just gives you a little bit more precision of how to control your server-side application. Let's see, these are somewhat similar. Namespace. So basically a new option to query data store stats on a namespace by namespace basis. So it gives you a little bit more granularity on the overall functioning or performance of your data store. Okay. There's been some updates in the admin console. So task queue, there's now like a details page. And also like the overall task queue size has actually been increased up to 1 megabyte. And then, yeah, I think that's mainly it. So these are also some features that have been talked about quite a bit. For example, at Google I/O, there were some talks about full text search and MapReduce. So full text search, and I should definitely qualify. Full text search is one of the popular features that people are asking for quite a bit, and there is work going on. But unfortunately, it's not available yet today. We did have some of our engineers explain the current work in progress at Google I/O. And so it is in progress, but it's not available yet today. And unfortunately, I don't have an exact, I'm not able to give like a exact time frame for when it is available. But I can assure you that it is being worked on, and it's a very popular feature. So essentially, the ability to have searching, a lot more powerful searching capabilities on your overall text data, like a search engine. So that's good. MapReduce. MapReduce is also another very requested technology. Part 1 is actually available. It's been out there for a while. It's essentially the mapping part as opposed to the reduce, shuffling and reduce section. So it's kind of like a multi-step process. So you can actually try out the mapper technology or MapReduce. It's via an open source technology or open source website that has the code, and it also provides like some simple examples of how to start it. So depending on time, I might jump in and do a demo for that. Let's see, some other ones worth mentioning. Yeah. Oh, I went backwards. Sorry. Yep, I went backwards again. Sorry, this is not my remote, so I'm kind of like guessing. There we go. So yeah, actually, I can do a few more demos, and then we can probably go into QA. So let me show you a few things just for fun. Let's see. I can really, yeah. I can show you a little bit of MapReduce. Let's do the fun one here, which is the channel API demo. So this is a feature, it's not brand new, but it's been out there. And for Google I/O, we actually put together a hands-on lab, and that you're definitely welcome to try it out yourself. But let me just close up a few things here really quickly. And I'm going to start it. Now I'm running it locally. Also, in case you're not familiar with App Engine development yet, this is Eclipse. It's running locally on my machine. I can then deploy it if I like to. But right now, because the SDK provides like a runtime server that I can debug, I'm actually running an application locally just to try it out. And so in this case, this is an application. I'll just create a new window. That's my sneak preview of something else. So this is a lab exercise that I'll show you where you can actually learn how to build it. So it's a simple application that goes out, it fetches news stories, and it takes them, and then it starts pushing them out to browser clients. So in this case, I could have one browser, I could have another browser, local host. Sorry, I have stuff cached. I have too many demos. Here we go. So now I have two browsers that are now connected to my server, and so my server is ready to start pushing out data. And what I have a cron job that goes and fetches news stories and stores them locally. And so now my two clients are connected, and all I have to do now is start a, oops, sorry. Start pushing out those messages. Yeah, there we go. So this is now starting up the messages. Sorry, I got too many windows. Let me just get rid of that one there. Yeah, boom, there we go. Now it's starting the messages up. So I should be able to get my, too many windows. There we go. Okay, so this is my Chrome browser, and what it's doing is now receiving a stream of messages that are coming in. And if I go back to, I can just open up another browser. Yeah, so this one's now connected as well. And it's also receiving the stream of news messages that are coming down. So this is like a simple example of how you can use the channel API to do server-side push to the browsers themselves. And so before I finish up, what I'm going to do is also just show you where you can actually download this. And I'll make sure that this link is in there. It's a short link. But basically, you can build this exact demonstration that I just showed you, both in Java or in Python. So this is part 3 of a code lab that we showed also at Google I/O. It was also a Google I/O bootcamp. Okay? So let me do another demo. I'm going to shut this down, and we can jump into, I think, yeah, let's go ahead and do the backends. So backends, as you recall, are the ability to have server processes running indefinitely. And the way you set the processes up is that, first of all, you can define in an XML or a YAML file. So I'm a Java developer. I can do Python, but I also tend to start with Java. So in this case, I'm going to build a simple back-end application that has the ability to go out and say, fetch the news content. So it's kind of based on that previous demo. But so this now is going to use a long-running process that will just continuously fetch data out on the web, so like news feeds and so forth. So in this case, the first thing that you want to do if you're going to add a backend to your application is you'll define a backends.xml or backend.yaml. And then in this case, I can define some of the options. Now, it just so happens that B1 is like the simplest instance that I can define. I forget the exact, I can pull it up, but basically I didn't want to really pull up too much resources. I just want to have a very simple instance available, and I'm also specifying that it's dynamic. So that way it won't start up it won't start running immediately until it's asked to do so. And then also I can set another option to make it public. So that way anyone can address this particular backend. So I can make it serve up data with really anyone as opposed to having to define specific access. Okay? And in this case I have just like a set of servlets that will fetch the news and stuff like that. So the first thing that I want to do is go ahead and start up the application locally and just see that my backend is defined correctly. And so in that case, I'll just go here. And a real simple way that I can do is I can go to the admin console. So this is a local administration console that I can use to more or less approximate what the runtime will be once I deploy it into the cloud. And as you'll notice here, there's a link here that says backends. And there it is. It's running locally. The backend name is newsfetcher, and it's going out, and I can actually see the data that it's pulling down. So I have news data that's coming down from the backend. Now later, when I want to go ahead and deploy it, currently the way you do it is you deploy the application, obviously. So I'll just go ahead and deploy this one just so you can see what it looks like. So while that's deploying, there's also a manual step still where I can deploy using the app config, and I can specify that I want to update. So if I want to update any backends, I don't have to deploy the entire app anymore. I can just go ahead and call this routine right here to update directly. And I'll just go ahead and do that really quickly. And so now my main application is deployed, and here I'm just re-uploading my backends. And when that finishes, I'm going to go ahead and pull up the actual cloud console. How are we doing on time? 5 minutes. Good. And let me just pull up my application. And in the same manner, I have a backends defined because I've defined it in my cron.xml. And it's running. It's a dynamic, and it's public. It's currently running. I could stop it if I wanted to. So this will stop it immediately, or I can turn it back on again. So I'm now turning back on that virtual instance there. And I could even click on this. And you'll notice here, that's the name of my backend. And the backend is independent of my other main application. So you could just think of it as a carbon copy of your main application, but with a different runtime environment. Okay? So I think we're ready to go for questions. How are we doing questions-wise? Shall we go into? Oh, we have to finish up because it's 11:40? Okay. Shall we take a few questions still? Yeah, okay. Look at it.
I don't know. Yep. I don't know if IMGym have a application to migrate, for example, of my SQL to data stored, migration tools.
Yeah, so there's not like a simple migration. So the question was, can you migrate a SQL data into your data store? There is not a one-click migration utility, but typically you could dump the data into a intermediate form and then use various upload utilities that we do provide, bulk loader and so forth, that do allow you to pull your data back into the data store. But it's something that is kind of done on a manual basis for that. Because the data store is different. It's not a SQL database. Now there is a new feature coming up that I'll talk about later today, a SQL service that is relational database, but the data store itself is not relational database. It's a NoSQL. Okay?
Okay, thanks.
I'll just be outside and I can take further questions if you guys have further questions. And I can even, puedo hablar en español contigo también. Okay? Bueno, muchas gracias. Okay.
Thank you, Chris. Thank you very much. Bueno, la sesión ya ha terminado y tienen en su agenda para ver cuál es la siguiente. Y los que no se vayan a quedar les pedimos De todos modos, todos desalojan, ¿verdad? Todos desalojan el área, por favor.
So I think that ate up a chunk of your time, sorry.